let's discuss on the next topic of the chapter, which is function. Functions is something which we have already discussed in your class 11. We had named certain functions like identity function, constant function, signum function, greater integer function, modulus functions, etc. Now, let's see what is a function. Here, a function is a connection between two set A and B such that all the elements of A, I repeat, all the elements of set A are associated with some element in B. That is the first condition to be a function. So, I repeat, for two sets A and B, the function is from set A to set B. All elements in A, I repeat, all elements in A are associated to some element in B. All element is associated to some element in B. And secondly, this association is unique. This association is unique. That means there are two things which makes a relation to a function. Relation means what? It is the ordered pair that's so formed under a particular given condition, where the elements were so chosen that the first element was from the domain of this relation and second element was from the second set in the relation. Now here when we deal with functions, a relation is now becoming a function from set A to B if for every element in A, is associated to some element in B, as well as this association so formed is a unique one. I shall explain to you in further. I have taken two sets, set A and set B. I have a relation R here, defined as R is equal to set of ordered pair XY such that Y is the mother of X. Y is the mother of X. So, I am trying to explain this in this diagram is called an arrow diagram. So, in this arrow diagram, I am representing that. This set A is the set of children in a community and set B is a women folk in the community. Now, if you look at every child has a mother, a biological mother. Now, this child 1, C1, I notate child 1 as C1, is associated to this mother or this woman W1. This child cannot be associated with any other mother. Can a child have two biological mothers? No. So that means a child is associated to only one mother. A mother can be associated to two children, isn't it? This child also can be associated to this mother, right? But no two elements can be associated to, no one element from here. Single element from here cannot be associated to two mothers. One child cannot be associated to two mothers, but a woman or a mother can be associated to two children, right? A mother can have two children. So, this way I can say that for every element that belongs to this set A, for every element of children here, will have mothers to the other set. Am I clear? So I can say that C3 is associated to C4, C4 is associated to W5, C5 is associated to W7. Right? That is, all the children are having their mothers this side. Every child will have a mother. So every element in set A will be associated to some element in set B. Some element in set B. But there will be elements in B who doesn't have children, right? So that way it is possible. Now every element of set A, that comes to the definition once again, every element of set A is associated to some element in set B, and this association is what? Unique association. This association is unique. Am I clear? So this relation R, I can conclude, this relation R becomes a function. When do the relation R becomes a function? A relation R defined from A to B becomes a function from A to B when these two conditions satisfied. All elements of A are associated to some element of B, and this association must be a unique one. This association must be a unique one. So that defines the function. That defines the function. Am I clear? Okay. Just have a look of the definition and this thing. If you can remember this, children, that is, A is a set of all children in a community and B is a set of women in the community, and every child has a mother and the mother is unique, right? So we are talking about biological mothers, okay? So mother is unique. Am I clear? So if you can remember this arrow diagram, then things are much clear. Now let's see an example here. Let X be the set 1, 2, 3, 4 and Y be the set 1, 5, 9, 11, 15 and 16. I have certain functions here. I have certain notations here, F1, F2 and F3. And it is given as the ordered pair, set of ordered pairs. We need to check on whether these F1, F2, F3 which are given here are functions or not. So in order to check for functions, what is the first thing? As we know, every element of this X. Now here this F1, F2, F3 are from X to Y. Okay, F1, F2, F3 are from X to Y. Okay, so now that's complete. Now F1 is a set of ordered pair which is notated like this. Now here the first elements, which are the first elements? Now you know that from here if you take the set of first elements gives you the domain of the function. So 1, 2, 3 and 4. I have it as 1, 2, 3 and 4. Now this is exactly what the set X, right? It is exactly set X. For every element X, 1, 2, 3 and 4 in X, you have a image 1, 11, 1 and 15. Image is repeating, that's fine. But none of the elements 1, 2, 3 and 4 are what? Repeating. I repeat, none of the elements 1, 2, 3 and 4 are repeating. So, what can I say about this? And these elements are what? Unique ones. That means 1 is having 1 only. There is no other ones here as the first element. 2 is having only 11, no other thing here. 3 is having 1, 4 is having the image as 15. So, none of the first elements are being repeated. So, what can I say? This F1 is a function. This F1 is a function. Now, coming to the F2. See, 1, 2 and 3. Do you have 4? Do you have 4? Does 4 have an image there? Is 4 there in this ordered set of ordered pairs here? No. So, according to the definition of a function, all elements in A must have what? Should have an association to some element in B. So, here, since 4 doesn't have an association to any of the elements in B, this F2 is not a function. This F2 is not a function. Now, coming to F3. Which are the first elements? 1, 2, 3, 4 and again you have a 2. Now this 2 is associated to 2 different elements. What is it contradicting? It is contradicting the statement that the association is unique. 2 should not have 2 images. 2 cannot have 2 images, 2 different images. So F2 and F3 are not functions. F1 and F2 and F3 are not functions. Only F1 is a function which satisfies the given conditions of a function. Now let's have another example here. Here you have f of x is equal to x square for the values of x lying between 0 and 2 and 3x for the values lying between 2 and 10. Now what is f of 1? What is f of 1? That falls for this particular relation, that is, inside this particular interval it comes. The value of x is equal to 1 is coming in this interval. So I have f of 1 is equal to 1 square, which is 1. You take 1.1, f of 1.5 you say. 1.5 means what? 1.5 the square, which is 2.25. Right? That also satisfies for this particular equation of the function. Now for the value of f is equal to say 5. What will be the function's value? For the value of 5 lies in this interval, the function value is what? 3x. So I have 3 times 5, which is 15. Am I clear? Even if it is for f of 10. 3 times 10, it comes for this function's value, that is 3 times 10, that is 30. But now, when the function's value, when the x value in the function takes the value 2, when the x value is 2, what do I have? This as well as here. In this interval as well as in this interval, 2 has 2 different functional values. So what do I get from here? From the first case, in the first interval, I get it as 2 square, which is 4. And in the second case, for the same function, the functional value is different. But it is given as 3 times 2, which is 6. Right? That means here I can say that 2 is associated to 4 as well as 2 is associated to 6. Now children, just think about it. Can 2 have 2 different images? Can 2 have 2 different images? This is according to the second part of the function becoming wrong. What is that? Second part of the function says that the association is what? Unique. For every element that belongs to the domain of the function, the image must be unique. The association of every element in the domain of the function must be unique. But here the domain of the function has 2 in it. 2 has 4 as well as 6 associated with. 2 is associated with both 4 and 6. That means this association here is not a unique one, and hence I can say that this f of x is no more a function. Got it? Yes. So these are the examples which I would like to discuss with you on functions, and now we are moving on to the next topic, that is types of functions.